30 feet. That's the entire distance separating Lake Powell from a line so critical that if the water crosses it, Glen Canyon Dam stops generating electricity completely, and two states start losing water they've depended on for over half a century. Not eventually. Not in some distant worst-case scenario. 30 feet, at current decline rates, in a lake that's been dropping for over 2 decades straight. And almost nobody outside the water management world has ever heard the number that actually decides what happens next. Here's what makes this different from every other reservoir story you've probably seen. Lake Powell isn't just a lake running low, it's half of a 2-part machine. And the other half, Lake Mead, is already in crisis of its own. Whatever happens to Powell doesn't stay at Powell. It moves downstream, foot by foot, into a system that has almost no room left to absorb another shock. Let's start with what Lake Powell actually is, because most people picture it as a postcard, not a piece of engineering under threat. Formed by Glen Canyon Dam on the Utah-Arizona border, Powell is the second largest reservoir in the United States. A reservoir so massive it took 17 years just to fill for the first time after the dam was completed in 1963. At full capacity, it stretches back through red rock canyons for over 180 miles, storing enough water to supply millions of people across the desert Southwest for years, even if the river feeding it went completely dry. That storage capacity was the entire point. Build something big enough to absorb the Colorado River's wild swings between drought years and wet years. And you never have to worry about a single bad season again. For decades, that plan worked exactly as designed. Then the math started catching up with it. If you've ever seen photos of Lake Powell from the air, the decline isn't subtle. The same pale mineral ring that marks Lake Mead's shoreline wraps around Powell's canyon walls too, in places climbing well over 100 feet up the sandstone. Boat ramps built decades ago at what used to be the waterline now end in dry, cracked rock hundreds of yards from the nearest water. Marinas that once floated directly on the lake have had to relocate multiple times, chasing a shoreline that keeps retreating faster than infrastructure can follow it. This is a reservoir where the geology itself has become a running measurement of exactly how much water has already left. Just like its downstream twin, Lake Powell generates electricity through hydraulic head, the simple relationship between how high the water sits and how much force it delivers when it drops through the turbines at Glen Canyon Dam. Higher water, more power. Lower water, less power, until you hit a threshold where the physics stops being a matter of degree and starts being a matter of complete shutdown. That threshold is called minimum power pool, sitting at an elevation of roughly 3,490 feet. Below it, Glen Canyon Dam's turbines can no longer generate electricity at all. Not reduced output. None. As of the most recent readings, Lake Powell sits only about 30 feet above that line. 30 feet on a reservoir that has already fallen more than 170 feet below its historic full pool elevation. In one of the driest extended stretches the American Southwest has recorded in over 1,000 years of tree ring data. So what actually happens if those 30 feet disappear? Start with power, because the consequences here reach further than most people realize. Glen Canyon Dam doesn't just supply electricity to nearby communities. Its hydropower feeds into a grid serving parts of Arizona and Wyoming directly, along with utilities and tribal nations across the broader region who rely on it as one of their cheapest, most reliable power sources. Lose that generation entirely, and every one of those utilities has to buy replacement electricity from natural gas plants instead, often at 2 to 3 times the cost. That's not an abstract line item. That's a bill that lands on rural cooperatives and tribal utilities with the least financial cushion to absorb it. The same pattern already playing out downstream at Hoover Dam. Except here it would happen all at once, the moment the turbines go silent, not gradually as machinery gets retired 1 unit at a time. But power isn't even the most dangerous part of this number, because below minimum power pool sits an even more severe threshold. Deadpool, the elevation at which water can no longer physically pass through Glen Canyon Dam at all. And this is where the two-state problem actually begins. Lake Powell doesn't just generate electricity, it's the entire mechanism that delivers water downstream to Lake Mead, which then delivers water through Hoover Dam to Arizona, Nevada, and Southern California. If Powell approaches Deadpool, water managers lose the ability to reliably move water downstream through the dam by controlled release. Arizona and Nevada, the two states most dependent on that downstream delivery for both drinking water and agriculture, would face a supply crisis with almost no precedent in the history of the Colorado River Compact. Not reduced allocation, a structural inability to move water through the system that was specifically engineered to prevent exactly this scenario from ever happening. Now here's the part of this story that almost never makes it into the panic version, and it's worth sitting with because it changes what 30 feet actually means. Lake Powell and Lake Mead are not independent systems making independent decisions. They're managed as one connected reservoir, and when one starts approaching a critical threshold, water gets moved between them deliberately to protect whichever dam is closer to catastrophic failure. In recent years, federal water managers have already ordered emergency releases from reservoirs hundreds of miles upstream of Powell, specifically to buy it more elevation, pulling water down from Flaming Gorge Reservoir on the Wyoming-Utah border to keep Glen Canyon Dam's turbines running just a little longer. That's not a hypothetical contingency plan. That's already happened, more than once, and it's worth understanding exactly what it costs to make it happen. Releasing water from Flaming Gorge isn't a simple valve turn. It means deliberately lowering a reservoir that Wyoming communities depend on for their own recreation economy and water supply, sending that water hundreds of miles downstream through the Green River into the Colorado. Purely to prop up a dam most of those communities will never see in person. Wyoming's own water officials pushed back hard on this, warning it would likely close boat ramps and hurt local businesses that depend on a full reservoir every summer. The releases went ahead anyway, because the alternative, letting Glen Canyon Dam slide toward Deadpool, was judged the greater risk. That's the actual mechanism keeping this system from a total collapse of its own thresholds. Not the natural cycle of wet years and dry years, but constant, deliberate, expensive triage between reservoirs that all have their own communities depending on them, which tells you something important about how this crisis actually unfolds. It's not going to look like Lake Powell quietly crossing 30 feet while nobody pays attention. Every time the reservoir has approached a critical elevation over the past several years, deliberate, expensive, politically painful intervention has followed. There's no version of this system where one state's water gets protected without another state feeling the cost directly. And that's the real shape of the danger here. This isn't a story about one number ticking down in isolation. It's a story about a river system so fully overcommitted that protecting any single threshold means deliberately sacrificing margin somewhere else every single time. The 30 feet separating Lake Powell from turbine shutdown isn't just about Powell. It's the visible edge of a much larger negotiation happening constantly, mostly out of public view. Between 7 states that all need water, the river simply doesn't carry in the quantities everyone was promised back in 1922. So picture what actually happens as those 30 feet close, because it won't look like a single dramatic headline. It'll look like what it's looked like every time before. A federal agency quietly authorizing another emergency release from an upstream reservoir most Americans have never heard of. A state water commissioner somewhere fielding angry calls about closed boat ramps. A utility adjusting a rate schedule that ripples out to customers who have no idea Glen Canyon Dam even exists. 7 state governments, already behind on their own negotiation deadlines, facing slightly less room to maneuver than they had the month before. No single collapse, just the same quiet, incremental narrowing that's been happening to this entire river system for over 20 years. This time centered on a reservoir most people only think about when they're looking at vacation photos of red rock canyons and turquoise water. Here's what makes this genuinely different from a simple countdown to disaster, though, and it's worth being honest about it. Reservoirs, unlike concrete, can recover. A single exceptional snowpack winter has, in the past, put back 20 feet or more across this system in a matter of months. Nobody managing Lake Powell believes crossing that 30-foot margin is inevitable on any fixed timeline. But nobody believes the underlying math has changed either. The river has never reliably carried what it was promised to deliver, and every dry year spends down a cushion that was already thinner than it should have been for over 2 decades. 30 feet isn't a prediction of collapse. It's the current distance between business as usual and a genuinely unprecedented failure in how this river gets shared. A distance that's shrunk before, been brought back before, and will very likely keep doing both for years to come, one emergency intervention at a time. If you want to see whether this year's snowpack numbers hold that 30-foot line or force another upstream release to protect it, subscribe, because Lake Powell is still moving, and this story updates every time the number does.